Hello people, this is Dr. Wang here recording. In this video, I'm going to talk about the Black-Scholes model, and we're going to use Excel to uh, estimate the value for call option and put option based on the provided stock information. So this is the formula for Black-Scholes model. So basically it's used to estimate the call option value and the put option value based on several factors. And the K here stands for the strike price of the option. The S here stands for the current stock value or stock market price. And you also have a normal distribution for a certain threshold value, D1 and D2. Since I have already covered normal distribution in a previous chapter, so I don't feel bad to add it here. So N basically will give you the probability for the values that is below this threshold D1, and also the probability for the values that are below the threshold of D2. So D1 and D2, again, they are determined by the stock price and the strike value of the option, and also the risk-free rate, and of course, the volatility of the stock price. So we do not study how to derive these formulas. That is for the Nobel Economic Prize winner, like Robert Merton from Harvard University. So we're not gonna uh, take his path to do this derivation for these formulas. So all we need to do here is to apply it in Excel and eventually develop the option value. And after that, we're gonna learn whether there's a monotonical relationship between certain factors like stock market price, uh, option strike price with the options value. Okay, so here you have the current market price as $10, and the option strike price, no matter for the call option or for put option, is also $10. And you also have the risk-free rate of 4%. So that basically uh, is the discount rate we use to take the time value effect, because this option do not get exercised until a year later. So the term here is for 1 year. All right, so the risk-free rate is 4%, so that's the discount rate for the time value of money. So because the strike price is a year later when the option get exercised or not, and the S0 is the current market price. So you can see the 1 year difference. So that's why we need to discount future value to present value. And there's also dividend yield need to be considered. We just put it as 0. That's one of the assumptions for Black-Scholes model. And also for the daily volatility, that's the most important one. We use option to hedge the risk. So if the stock is more risky, then definitely the option value would be higher. So the number one thing you need to estimate, you can just follow my step here, is to use, okay, the ln, okay, the natural logarithm of this current price divided by the strike price of the option, no matter for call or for put. You're gonna solve for D1 and D2, the threshold for the normal distribution probability. And then you're gonna add, all right, don't forget to use the parentheses, and then you're gonna add this part, which is the risk-free rate 4% plus the squared standard deviation of the stock 30%. That's very easy to estimate. Divided by 2, and then times number of terms. So if the option lasts for a year, then this should be 1. If it lasts for 2 years, then this should be 2. If it lasted for 3 months, then this number should be 0.25. All right. So after that, don't forget to use a set of parentheses to include the numerator, and then we work on the denominator, which is the volatility times the square root of the term. So far, so easy. And for D2, you are going to use the D1, of course, is right here, minus the square root uh, of the square root of a term times the volatility. You see, D2 is also taking a complex the formula. The difference The only difference here from D1 is that it uses R minus square root sorry, the variance or the square deviation divided by 2. Right here, they use the um, adding sign, the plus sign. Here, they use the minus sign. Okay, so after that, then we will need to get the option, the value for the call option. So you are going to use this stock current market price as 0 times normal distribution. So that's going to give you the probability uh, for the value that is under D1 is threshold, okay, in percentage, of course. And be careful, you should use normal distribution. So there should be a S here. So if you don't put a S, then that is something else. So in the middle, you should put a S. Then this value in the parentheses would be the Z value. And then this function would give you the probability under normal distribution as we desire. Okay, and then you're gonna subtract the, okay, this is the formula, subtract the strike price times the exponent, okay, the exponent of, all right, negative 4%. So this is actually the negative sign times the 4%, all right, times the term, all right, and then times the normal distribution, the probability of the values under this threshold of D2. So you just use a normal distribution function Excel, very handy. You put the Z value here, the threshold D2, okay, and then you hit enter. So the option value should be 1.38 for this call option. And for the put option, you're gonna use something opposite. So first of all, you're gonna start with the strike price here, B2 times the exponent. Let me replace this, negative risk-free times the term, okay? And then the times 1 minus, okay, the normal distribution of a B2. So it's very important. So when you have the negative threshold, okay, so you don't put this negative B10 or negative D2 there. Okay, B10 is the D2 I have calculated. You don't do that. Instead, you use 1 minus this normal distribution of the same Z value, okay, D2. That's how we do it. Likewise, for this part, we use 1 minus the normal distribution of a B9 instead of using normal distribution of a negative B9. So that's how we do it. Just be very careful about it. And then you're going to have the put option price listed. Okay, so the calculation here is just a copycat. As you can see, I just followed the Black-Scholes formula, and this was a very widely used when it was invented back in 1990. So what I want to show you here is I'm going to replace the strike value, okay, the strike price here, and I want you guys to observe this call option value, okay, and see what happened. So if the strike price goes lower, then the call option value would get higher, as you can see, and the put options value would get lower. Okay, so that means when the strike price is lower, that means you can buy at a lower value. Okay, if you exercise the call option. Okay, so that's better if you can buy at a lower price. And if for put option, it's a different story. So that means you're gonna sell at a lower strike price. So definitely that's worse. So the put option value would get decreased. So let me highlight this one as well. Okay. So if I increase it, so 12, so if the strike price goes higher, as you can see, the call option value is reduced because you have to pay more when you exercise the call option to buy the stock. And the put option value will go up because you can sell more at the strike price for the same stock, and that's better. All right. So and also I'm going to increase the volatility. So if the volatility changes, let's say from 30% to 50%, the stock is more volatile. As you can see, both call option value and put option value increases. As I said, the option is like an insurance plan, and the insurance is more expensive if there's more risk in it. So when the stock has a high volatility, then the value of this call option and also for put option will get larger, and vice versa. If the daily volatility is reduced, then you can see the option value is also reduced by a great deal. Okay, so what about terms? So if the term is longer, then you can see that there is a increase for both options, both types of options. So if it's reduced, then you can see the value is reduced as well. So term also means is also a implication of a risk. So if there's longer term, that means more uncertainty get involved, not just the past volatility of stock price, but also some of future unpredictable events could be involved. So the term also have a effect on both call option and put options. Okay, and then I want you guys to observe this. So what about the current stock market price? So if the stock market price goes up 15, so who will be happy? The call option buyers or call option holders will be happy because they can sell this, they can buy at $10 and sell at $15. This call option is in the money. Therefore, the call option would be worth more. If the stock price is less than $10, then the call option will be worth less. Okay, and if the stock price is lower, let's say $5, as you can see, the put option would be more valuable. It's because the put option buyers or holders would be happier when the stock price dropped below the strike. So that means this put option is in the money. The put option holders can sell the option at $10 and simultaneously buy at $5. So that's pretty good, right? Therefore, the put option has high value here. Okay. Okay, so now let's estimate the data. So data basically is the sensitivity of option value to stock value. All right, you see options, we call them derivatives because their value is derived from their underlying assets. And if we want to get to know the sensitivity here, then first of all, we need to generate a column of a stock price. So I'm going to use 0 and increment by $0.2. Okay, sorry, $0.2. And then I will increase it all the way to maybe 0.5. All right, to make it easier for you guys. Okay, increase to $20. Okay, and then we try to get the option value. Let's see, call option value. All right, so what we do here is I'm going to use the data table function, and I'm going to replace each of the stock price here to this cell and record what the call option value would be. Before I do that, I need to insert a benchmark table, benchmark row, and that basically need me to put this call option value that is calculated based on the given data. All right, so let me just select everything here. All right, and then I'm going to use the data, and then I have what if analysis, then data table. So all the numbers here to be replaced, to be used as replacement are in the column. So I'm going to use this part, and all the numbers here will be used to replace this cell. So I just click on it, and then data table will automatically generate the call option values. As you can see, this is it. So basically it says that if the stock price is too low and there's basically no values for the call option. Okay, let me just change the format to it. Okay, so if the stop price is too low, then the call option would be worthless because you don't want to buy at a strike and when the stop price is zero. Okay, you see if I put zero there, then this doesn't make sense. Okay, so if the stop price is zero point 0.5, that means still the call option is so worthless. You can't just um, nobody would want to exercise it. If you exercise it, you basically are paying $10 and sell at half dollar. Nobody want to do it. So there's no usage for this call option. Okay. So when the call option, when the stop price keeps increasing, as you can see, the call option price also increases. All right. So if I do a chart here, select it all, then I do insert, and then this chart. Okay, so you could see that the option value just keeps increasing as the stop value goes up. All right, so that's um, the trend between the option value and the stock price. Okay, so what's the data for this one? So I'm going to use the slope of it. So I can just use a slope function and use the option value as the y-axis. That's the dependent variable. It's determined by the x values here. Okay, then you can get the slope of it. So that's the sensitivity, and that basically is the data. And the data basically tells you that when the stock changed by $1 and the option value would change by $0.55. And you can do the same thing for put option value. I'm not just to do it here. I really want you guys to do it as an assignment.